Okay, good morning, everyone. Thank you for attending to this first session of the BPN Industry Forum. And let's start with the first presentation, which is titled Trace Clustering for an Online Freight Exchange at Timocom. And the presenter is Jens Brandt. You have about 10 minutes for your presentation, and we will have 4 minutes for questions and answers. If someone wants to make a question, please raise your hand in Zoom. And at the end of the presentation, of each presentation, we will open an 4 minutes question answering turn. Then you have the word, Jens.
Thank you very much. I will share my screen now. Could you confirm that you see it?
Yes.
Okay, great. Okay, hello everyone. My name is Jens, and on behalf of my co-authors from the University of Münster, the VID IT Consultancy, and Timocom, I will present our paper on trace clustering for an online freight exchange at Timocom. Timocom offers Europe's biggest freight exchange platform, and with the help of this platform, or this digital platform, they mediate supply and demand of freight and cargo hold offers. And each day, up to 750,000 offers are published on this platform by about 130,000 users from 43,000 different companies. So it's a highly frequented platform. And as this platform is a quite central component to their business case, they obviously continuously try to identify weaknesses or improve this platform. So one approach that you can do when you talk about digital platforms and user behavior on this platform is to somehow visualize the click paths and the usability of this platform by your users. For example, by visualizing them in business process models. However, as mentioned, the platform is quite highly frequented, and there are many different functionalities involved. So if we were to simply, for example, use some process mining approaches here, we have the challenges that we have quite large amounts of data, which would lead to very complex process models. And also something that Timocom already knows is that they have rather heterogeneous user groups, which use the platform differently. So if you would just put all the data into one process model visualization and analyze this, then it would be quite hard to uncover user group specific insights. Therefore, if we already talked about process mining, I think everybody in this conference has at least a general knowledge about how we use some event log data to create a digital process model, which we can then visualize in form of, for example, here, a rather complex visualization of a process model as a graph. So what we do is, if we add trace clustering, is we basically add another step before the creation of the process models, and we try to find as homogeneous groups as possible within the event log traces in order to reduce the complexity and create various different process models of different groups, which then are less complex and also easier to analyze. To be able to find out which trace clustering approaches that already exist in the literature are most applicable or working best in our case, we performed a literature review on trace clustering approaches and identified that there are 3 different types of approaches that you can do for trace clustering. Just very broadly, due to the time constraint in this presentation, there are trace sequence-based clustering approaches where you take the linguistic exact view of the trace that you have So you don't extract any features from it and then create some kind of a distance matrix to identify how similar a number of traces are to each other. Second type of approach would be the feature vector-based clustering approaches, where you interpret the different traces, so the different activities of the users in a more abstract way. So you generate different features from them and then take these features as a basis for the similarity of the different traces. And the third, very much different approach would be model-based clustering approaches such as ActiTrack, where you focus more on the resulting visualized process models and their complexity rather than on the features or the linguistic exact view of the traces. So here the goal would be that you group together such traces that the resulting process model visualization is the least complex. To evaluate the different approaches that we found in the literature, we developed a solution architecture that looks like this. So we did not implement all these approaches on our own. There was just no time for this, but what we did is we had different data sources from a database and a data lake. We implemented a pre-processing module which outputted some raw data for those models, those methods that needed these. We outputted the trace sequences for the trace sequence-based clustering, and then different features for the feature vector-based clustering. And whenever possible, we implemented this based on Apache Spark, so that it will scale to big data, which we have on our hands here. And we then fed these inputs to the different already implemented methods. For example, we used the process mining workbench for the model-based clustering approach that I earlier mentioned. We then were able to use R-based trace sequence-based clustering and feature vector-based clustering approaches, which we implemented, as I said, in Apache Spark, and then fed these all into a visualization evaluation module. Based on a number of evaluations that we've run on different data set selections, we in the end ended up using a trace sequence-based clustering approach with the Levenshtein distance and partitioning clustering with 5 clusters, which means that given the overall process log, which you see on the top here, we were then able to generate 5 different subcluster groups, which of course are still rather complex in this very high-level presentation. But on closer analysis together with the colleagues of Timocom, we were actually able to identify the different user groups that I mentioned in the initial slide. So the 5 user groups that we identified based on these user groups were the occasional user, the full-time all-rounder, a hardworking user, a passive user, and a specialized power user. And they all exhibit quite different usage behavior. So for example, the occasional user is the majority group with about 70% of accounts, which however only account for about 13% of all the activities. They have a rather low activity, but they do use many different functionalities. On the other hand, for example, a quite interesting user group is the passive user, who also exhibits rather low activity, but mostly uses functionalities such as auto refresh runs to automatically update search for freight offers and stuff like this. And something also very interesting was the specialized power users, which nearly exhibit like robot-like behavior. So they are really task-specific activities. They have high activities, so they are really active. And for example, we identified them as, for example, employees with the exclusive task of searching for very specific offers or stuff like this. Based on these user groups, we then looked into the different visualizations and the different clusters that we identified, and identified a number of design application improvement capabilities one of which I would at least like to show here in this presentation. So as you can see here in the visualization in a second, this is the visualization of the occasional user, where you will see that the auto refresh functionality, which we'll zoom in now, is not so often used. However, if we go further to the right on this visualization, then we see that the manual actualization of the show freight functionality is used very, very often by the user. This was also shown in different user groups, all but the passive user. So what the colleagues from Timocom found out later on is that the auto refresh functionality does not update as live as you would like it to be. So all the more active users, for example, then use the manual refresh functionality that was also implemented instead of the auto refresh function. So some WebSocket based or more live implementation of the auto refresh functionality would be more meaningful here. There were other improvement capabilities also identified, but looking at the time, I will skip over these for the moment. So we were able, with our prototypical implementation, to identify cluster-specific issues, and then also identify improvement capabilities. For ourselves, we regard this pipeline that we implemented as a template for performing future trace clustering-based analysis, especially at Timocom. But looking at future work that we still want to do, of course, we need to generalize our results. So in our case, as I said, we found out that the trace sequence-based clustering approach worked best. However, this probably is not the case in all kinds of these applications. And also, even though we looked at, we tried to implement it in a way that all of the modules are scalable, especially all the things that work within the process mining workbench are not that scalable to big data at this point. So improving the scalability of the trace clustering algorithms would be future work for us as well. So thank you for your attention, and I'm open for questions.
Okay, thank you. Is there any question? If you have a question, please. Okay, yes. Okay, you can make the question, Will.
Yeah, so thanks for the presentation. What is often difficult with clustering techniques, and I think you gave a very balanced view of what exists, is the interpretation. And I was kind of surprised that in your slide you immediately made the step from, okay, we do clustering, and now these are the characteristics of the group. Can you say more about like how you characterize this? I think it's slide 8 that I'm talking about.
Yes, so
this is often the difficult step to something that was generated automatically to interpret it in this way. And you give many suggestions here, and I was wondering about that process.
Yeah, so the process involved multiple rounds with the practical partner. So some of this work is based on a student thesis that they did in conjunction with the IAD and the Timocom, and so we did multiple iterations here. So this is only the final result, and we also had different cluster results in between, and I unfortunately wasn't part of these discussions. So there were multiple experts involved from the practical partner who have knowledge about the process, and they looked at these very different process models. And I guess there's also they brought in some previous knowledge themselves, so they might have been looking for something like this but I wasn't involved there, so I cannot give you additional information here.
Yeah. Thank you.
Okay, any other question? And then, if we have not a question, we go to the next presentation, to second presentation. The title of the presentation, let me, okay. The title of the presentation, of the next presentation, is Process Mining for Production Processes in the Automotive Industry. And the presenter is Mary Seren Yusal.
Okay, so sorry for the entry, but my name is Sarah, so I'm participating in this conference. Can you hear me? Yeah, right?
Yeah.
Yeah, okay, I'm participating in this conference from RWTH Aachen University from Germany. So I'm going to present you our recent work about the process mining for production processes in the automotive industry. So this is a use case which was about electric vehicle company that a manufacturer for short distance traffic, also established in Aachen, and the company is called Ego Mobile AG. So they're a very young company, and it was an interesting opportunity for us within the context of excellence cluster in terms of production at our university, where we are interested in just building a reference model for the production at the university. So that was just a part of this project. And it is also, it's very interesting for us because they have production processes, and they have stations which we are going to see in the upcoming slides. And the operators and the supervisors, that means the human resources, are involved in the production processes as well. So one thing that's very interesting and very nice for us, building the basis for the digital shadow, because every step within the production process, it is recorded, and they are recorded, and we can find them in the information system so that we can generate or make the business analysis in the company generate the event logs. So we were able to just reach the event log and just use them for our process mining aims. That means we applied the process mining techniques on the event logs in order to discover some performance and compliance problems in the production processes, and we had interesting results. So I would like to start directly with the challenges that we had. First, let's have a look at the manufacturing process, so how it looks like. You can imagine that we have a general assembly line, so it's starting with the general assembly station 0, 1, 2, up to 28. So we have 29 stations. And we have also sub-assembly stations, that means sub-assembly lines comprising the sub-assembly stations. And these are connected or associated with just some general assembly stations. So what is interesting here? So we see here actually a very sequential production process. That means the car enters here the GA0, that means general assembly station 0, and then goes through these processes and comes out of the general assembly 28. Then the car is assembled completely. So what about the data set that we had? So the time range was about for 2 months in 2019. And it's important to mention that it was just a ramp-up phase. So it was not the real production phase because it's a very young company. And we had in total, so 116 cars. That means it corresponds to directly the number of cases in our event log. And we had 12,000, about 12,000 events where we have the case attributes and the event attributes. So what is case attribute? For example, it's about just a car property like car ID or a color or a release version, because we had also some different releases in the log. And we had event attributes such as what kind of event we have, what kind of activity it is, what is the name of that, and then what is the timestamp. So what about the challenges? We had at the very beginning, we had some problems with respect to the pre-processing data, because we faced the problem that there was some improper logging in the company. That means the start and the end time of the activities at the station levels, they were not always recorded properly by the operators. And we will see that on the upcoming slide. So we, for example, we had some batch operations where we had very similar timestamps to each other for many different cars. And this was not that reliable at the very beginning. And the other challenge was that we had the problem that the business analysts, they had to modify some timestamps in the information systems in order to comply with some rework operations, which are directly done at the end of the whole production processes. So after dealing with this kind of challenges, so the questions which also with the company together, also our questions were which station activities often cause a delay in the production process, and do observe patterns change over time. So how does it seems like, how does it seem like? And do the execution of the subassembly lines, and if they confirm with their normative models. So there were, these are, just 3 questions out of many other challenges and questions. And what we really did as a solution approach was first to apply the process mining methodology, so very well-known methodology, and we pre-processed the data, and this took a little bit long time for us. And then for the results, we use also the data chart to visualize the production activities over time. So where we have the events on the directly on the figure, we will see that. And we use the process mining for Python. This is an open source framework, and also pandas to generate the results. And we analyze the control flow behavior of the general assembly stations, which indicate bottlenecks or some problems in the production processes. And lastly, we will see that what kind of process evolution we have. That means when we look at the weekly basis, the process evolution, so what are the changes, what are the differences between those processes. So let's come to the results, which are actually very interesting for us. The first result would be then the data chart. And here we see actually a lot of interesting insights. So we see here on the y-axis, the IDs of the cars, so the vehicles. And on the x-axis, you see here the days, that means timeline. And here we see that each event, each dot on the on this figure, they are corresponding to one single event. That means, for example, leaving a general assembly station, or just completing a sub-assembly line for a corresponding general assembly station. So you see here, for example, some gaps or big gaps between these sets of activities. So this is corresponding to a weekend or a night. That means we see that there is no night shift or not weekend shift here. And as I mentioned before, so we have here some regular batching for certain activities. Here you see that actually for specific IDs, car IDs, we have more or less actually the same timestamps where we have the same event. So this is because of some improper logging issues. And also there is you see here this dashed line, red line, and it also corresponds to the production production speed. That means you see here a little bit steep slope here at the end. That means it corresponds to also an increase in production and the production process. And this kind of insights can be gathered out of the other chart. And what about the whole general assembly and the sub-assembly line? So you see here, with respect to the waiting times and services times, we had a small analysis here. You see here the blue and the red colors, they are corresponding to very high waiting times or the processing times in the general assembly stations and in between the stations here. And you see here, for example, GA16 is a real bottleneck. We really need to wait a long time in order to proceed to the next general assembly station. And when we go a little bit in, zoom in a little bit, then you'll see here that we have 2 subassembly lines, and the general assembly 16 is taking really a long time, and just before that we have a very long waiting time for entering the general assembly 16. So we will have a look at that later on. What we did was also to analyze the performance evolution on a weekly basis. So you see here 6 subsequent weeks, and you see here first the first week, I mean here just at the top, and you see here GA0 or 14 or 22, 24. So we have different General Assembly stations where we really have to wait for the processing time, and also there are many long, waiting times for I mean, in between stations during the General Assembly stations. So when we have a look at the process evolution and we come to the last week here at the bottom, you'll see that there are actually very small number of General Assembly stations where we have lower waiting time, processing time, and we have also, you see here a lot of blue waiting times in between the stations during the first week, but after 6 weeks we have that also as well very low. I mean, in a very small number of in between stations we have a high waiting time. All right. And another result would be then to examine the control flow. Here is an example. You see here at the right-hand side, here again, GA16, that means General Assembly Station 16, and it's directly associated with 2 subassembly lines, and starting with 5, 4, 3, and 2. So this is just one line going up, and the other one is the 8, 7, and 6. So these are also the subassembly stations which are directly connected to each other in order to come to the General Assembly Station 16 here, and you see here that we have the control flow over 92 cars that we have analyzed, and they are starting with 5 and 4. That means you see here 5 and 4, and then some cases, that means the 87 cases, the person cases, they go over the subassembly 3. You see here, so they're following actually this subassembly line, but some cases they do not follow this path. That means they're actually following the other path. That means 2 subassembly lines, they can work independently, and it can start actually also parallel to the other subassembly line and with subassembly 8. So the goal is to reach the General Assembly Station 16 here, and we can also analyze what kind of stations were on the let's say happy path or not. So there were actually many other results, but because of the time restrictions, we're not going to have all of them here. So what I have seen here so far, we applied process mining techniques and the methodology in order to analyze the production processes of the company Ego in Aachen in Germany. So we have seen the data chart where we have seen the events and also the batch events, or also the weekends and nights where we have gaps in the timeline. And we also analyzed the waiting and services times on the production process. So we have the General Assembly line and we have the sub-assembly lines, which were associated with the General Assembly stations. And we have analyzed the process performance on a weekly basis, where we have seen that we had at the very first week, we had very long waiting times and also long service times for many stations, but then it was reduced at the last week. And we have seen just an example of the control flow where we had bottleneck. So what we have, what we can say that the lessons learned out of this use case is if we have a higher data quality and the correct logging, then it is leading to a more reliable result. It's very important at the very beginning of the processes. I mean, just before starting the process mining. And what we have seen is like GA16, I mean, the General Assembly 16, a bottleneck station can influence the preceding stations really heavily, and we can really wait a long time in order to proceed to the next station. So what would be actually interesting solution maybe to that? We may consider bypassing bottleneck stations. That means just introducing some buffers. And the last point would be then just to consider some simulation approach. And we have already talked about them with the company. And but because of the current situation, the production has suspended, unfortunately. Yeah. So this is from my side. Thank you very much for your attention.
Okay, thank you. Any question? Okay. I have a question.
Yes.
Then how the resources of the process have impact on the result? That is, in the analysis of the bottlenecks, do you have analyzed the role of the resources in the results?
The role of the resources. So
Yeah.
you mean the role of the resources, for example, like the human resources as well?
Yeah. Yeah.
Okay, this is a very nice question. Actually, I was expecting that. Actually, the next step would be to just analyze exactly this kind of situations and stuff, because we know, I mean, not directly we, but the company knows very well at which stations, at what time, which operators or supervisors were working. So we were not able to analyze this kind of situations because we did not really have the data for that. But it was actually the next step to have a look at this concept. Yeah. So it's definitely very interesting and also very relevant to this use case, because there are some problems, there are some bottlenecks and deviations, and we would like to know, I mean, the company would like to know about why it happens and what happens, for example, if we change the order of the tasks in different assembly stations, and also the place of the operators. So if you change from one place to another place, what would happen? So this was actually the next step to do.
Okay, thank you. Any other question? Thank you very much.
Thank you.
Then the third presentation, the next presentation, is titled Geo-enabled business process modeling, and the presenter is Beshid Bekamal.
Hello all, can you hear me well?
No, we can't see your slides. Okay, I see myself.
I shared the screen. You cannot see that.
Okay. I can see now. Yeah.
It's okay now.
Yeah. Now it's working. Yeah.
Okay. Thank you very much for your attendance. I am Beshid Bekamal, faculty member at Turkish University of Mashhad and a member of the Technology Lab. On behalf of my co-authors, I want to present our work on geo-enabled business process modeling. My talk will be presented in three parts. First, I start with the problem we faced in the industry and propose our solution. And finally, I present our tool and solution in details. Our industry partner in this project was National Post Company of Iran. As we know, all the process model research focus on both inter-organizational and cross-organizational processes. In the cross-organizational process, you have two types of process. The first group act as puzzle pieces and work on a modeling on the same process instance. And the second, like the obtaining a building permit. And the second group of the process model, cross-organizational process models, act on the same infrastructures, but using the same process model with some customization.
Beshid, yeah.
Beshid, we can see your slides.
Yes.
I thought it was only me, but apparently there is this problem. We can't see your slides. We are seeing still the Zoom app, the Zoom. So we are seeing Manuel all the time.
Yeah.
I don't know what's the problem. I can change the internet connection.
I think you should use the Zoom client instead of the browser. I think you're having problems because of that, probably. So
yeah.
I suggest maybe I don't know, maybe we move on to the fourth presentation, and then in the meantime you try to install and join again from the client. Would that be okay?
I can change the internet connection. Okay.
Okay, I think that's yeah, the best thing now, so that we can continue with the session.
Yeah.
Good.
Then we go to the next presentation, and then we can start with your presentation. Then the next presentation, the fourth presentation, is titled Energy KPI Tracking in Building Construction Processes Using Adaptive Case Management. And the presenter is Antonio Manuel Gutierrez.
Thank you, Manuel. I'm going to share my presentation. Let's see if there is no problem. Okay. No, you are seeing the preview. Oh, yeah.
Okay, yes.
Now? Thank you.
Yes.
So, welcome everyone. As Manuel said, I am Antonio Gutierrez from ISIS Papyrus, and I'm going to present our work in collaboration with CES Clean Energy Solutions, which is a competence center for energy design and management, and the Austrian Institute of Technology. First of all, I would like to give you a scope of our project, and it is that the construction industry had problems about the digitalization because different aspects. First of all, because the building itself have very different features, become their purpose, like office buildings or residential ones. Also, the parties involved are usually from very different disciplines, like architects or electric engineers, which have their own way to work. Third, they also use different software, even for the same discipline. The architects can use different commercial tools like ArchiCAD or Revit. And fourth, we also have different national requirements, which constrain some of the aspects of the building, like the energy demand or spatial requirements. To address some of these problems, there is a standard called BIM, which stands for Building Information Modeling, which proposes a standard format to demonstrate the building modelings, also some communication mechanisms, and also propose the figure of the BIM manager to coordinate the processes between all the parties involved. CES use this standard and also an adaptive case management paradigm to manage their project. This adaptive case management platform is composed of these four main elements that we see. On the one side, we have the value streams, which are a value stream is a case which provides some benefit for the parties involved. For example, the definition of a new architectural model, which is the 3D model of the building, is one of these value streams with different sub-goals. The actions are another element. The actions are the supported tasks in the system to achieve these goals. So, for example, for the architectural model, we have actions related to upload architectural model, do some reviews, or taking decision about this architectural model. Third, of course, these elements, action and value stream, are based on a business information modeling and ontology, where the concepts related to these actions and value stream are defined, like the architectural model, which belongs to a building project, or the building physics model, which is the thermal properties of the building. And fourth, an adaptive case management needs the business rules, which support the user in which are the next action that he can do, what he should do, or to constrain what he can do. Now I want to show you some of the value stream that we are using in the project. As the title says, in this project is focused on the energy value stream. So for the energy, we have the main value stream, let's say, is the one related to defining the thermal properties, which is the building physics model. But of course, to define the building physics model, we need first an architectural model, the 3D design, and the building project itself with the global properties. This platform all these elements are defined in this platform with a component called Business Composer, where the business user, in this case the BIM manager, can define either the value string and their goals, the actions which can accomplish this goal, the business ontology behind these actions, and also the rules which constrain the actions in the value stream. Now I go to the challenges in this project. As I said, we focus on the energy, and in this project to follow the accomplishment of the project, different KPIs related to the energy are defined. On the one side, we have the heating demand, which is the needs of heating because of the temperature in the season or the materials in the building to keep some conditions for depending on the purpose of the building. It's not the same residential buildings as offices, or the family overheating, that is a kind of limit that we need to building companies need to check that in extreme conditions the temperature is not exceeding some legal limits in summer, for example, or in winter, depending on the region. So to define this, the problem of, let's say, managing these KPIs is that we work in a value stream basis, that is the same like a case basis. The different concepts in this in a project are managed by different cases. So we have a case to deal with the building project itself, another case to work with the architectural model, and another work for the building physics model. So when we want to support two basic operations for the KPIs, the first is monitoring the evolution of one specific KPI value, like the heating demand. We need to differentiate in this case, which are the heating demand values which are related to the same project, and to differentiate from the heating demand values that belong to different projects. The second operation that we want to support is assessing if this KPI accomplishes some KPI target that is usually defined in a global concept like the building project that is managed in a different case. So to support this operation, we take a look to the ontology fragment that is behind this concept. This is a simplified version just for the example. Now the heating, as we say, the heating demand value belongs to the building physics model, while the heating demand, the target, is related to the building project. So first, we extend this ontology with some generic concepts for taxonomy for this concept like KPI target and KPI measurement. And then for this special concept, we provide a predefined query of the path between the KPI target and the heating demand. So we extract all the concepts involved between these two general concepts. And with this query path, we can provide implementation of these two operations, the monitoring and the assessment. The monitoring is done, the assessment is done using the direct path between the heating demand value and the target. So when we have the instances that I showed you before, just navigating with this query path from the heating demand value to the heating demand target, we can compare if this value is accomplishing this target or is under this limit. And we use the opposite. Once we have identified the global building project, using the reverse path, we take all the instances that are related to the building project, so we can compare the trending in this KPI value. Doing this in this way, we can provide in the player of this system with actions to generate reports about the evolution of this one KPI. This player is intended not for the BIM manager, but for any business user, like the building physics engineer, and also to compare the current value the last value with this heating demand target. In doing so, we provide a mechanism so the business user can define these KPIs and also to generate these reports and use this action related to the KPIs without a specific IT acknowledgement like this ontology path between the concepts, so that they don't, let's say we provide a local solution. We also, not only for the BIM manager, for the business user, we provide this automatic KPI report. And this solution, and although we focus on the energy KPIs, is really independent of the business domain, not only energy concept, but other concept in the buildings, but not only also buildings, but any other business domain. And one of the problems that we found in this project is that the BIM standard really, although intends to cover this data format about building modeling, it doesn't cover the complete information about a building project. So it's one of the challenges to find how to extract this information about this KPI that is not usually found in a standard building model. As a future work, we intend to extend this action, this provided implementation with more complex KPI evaluation, like, for example, taking in consideration an aggregation of the previous values that we have not considered, like the example, as we say, cooling demand has to be 20% lower than the average of the previous cooling demand, or also extend to all the KPIs in the building project, not only any related, that is the goal of the content project. So this was our work. Thank you very much for attending. And I'm open to any question that you have.
Okay, thank you very much. Any question? Let me know, let me see. No, we don't have question. Okay, I have a couple of questions. The first one is there any kind of reasoning of the ontology reasoning, or the ontology is just for representing the concepts and relations between them?
No, all the system itself is based on the ontology, either the actions, the implementation of this action, the user interface is based on the concepts and the properties. So what we have on the user interface are directly the properties, and the user manage these values that are related to the behind ontology. Also the rules that we define on the system to drive the user, not to constrain, for example, if you cannot execute some action because some instance is missing, these rules are defined with a grammar based on the ontology also.
Then, continue, please. Yeah.
No, I mean that we presented last year. We presented a work about this system and about this focus on this ontology in an industry paper last year in a workshop last year in the BPM conference.
Okay.
Where we address this, how we work with the ontology to define all the rules, action, and value streams.
Okay, and the other question is the KPIs are global, or they are associated to some actions?
The KPI itself are global, but it's true that let's say either to display this evaluation, this report, or we need an action where we check, we query this, but we can use this evaluation in any action, in any part of the value, in any value stream, or in any action. So let's say they are global, but at the end we need to, the actions are the first citizen where the user interacts with the platform. So
okay.
Needs to.
Okay, thank you.
Yeah.
Any other question? No. Then we move to the next presentation, but I don't know if if it's available. Bishait, are you there?
Yes, I'm here.
Could you start your presentation?
Can you see my screen?
Yes, I see myself.
Oh, the problem not solved yet. And now you cannot see, okay?
Yes. Okay. I see your presentation right now.
Do you have it now?
Yes. If you put the presentation in full screen. No.
Okay.
Oh, okay. Yes. We are
now
seeing
you have the screen.
Yeah, we can see the PDF now.
Yeah, we can see the PDF.
No, now not anymore. Don't know why it's switching between probably different screens. Okay, we can see it again.
Yeah.
Stay there, please.
Yeah, now it's
okay.
perfect.
Sorry.
No.
Sorry. Okay, I will share the PDF again. Okay. I think there's a problem with my PowerPoint. Okay. I think it's okay now, right?
No.
No, it's still the same problem.
Yeah.
We have the same problem.
I think there is a delay.
Okay, now it's okay.
It's okay. Okay.
Yes.
I think there is a delay because of the internet connection in Iran. I'm so sorry about this interrupt.
No, no problem. But we are seeing the PDF. It's okay. Okay.
Okay. Hello again. I would like to thank you all for your attendance, and I do appreciate it. And again, I want to apologize all for this interrupt. I'm Behshid, and I want to present my work on behalf of my co-authors. The title of my work is Geo-enabled business process modeling. It's a case study from the transport industry. My talk will be presented in 3 parts. First, I started with the problem we faced in this industry, and then proposed our solution, and finally, I present our tool in details. Our industry partner in this project is National Post Company of Iran, NPCI, and as we know, we have 2 types of business processes. The first is inter-organizational process, and the second is cross-organizational process. In the cross-organizational business process, some of them act as puzzle pieces and work on the same instance of a process to execute the process. But the second group are the process that are executed by several companies with the same infrastructure, such as the branch of a bank or a parcel pickup and delivery process that we are going to report in this experiment. So the parcel pickup and delivery is a cross-organizational business process that each of its activities is performed in different geographic locations. In these types of business process, when the activities are executed in different geographic locations, one of the most useful information that we can apply for process analysis is the contextual information related to the location. In this company, in the Post company, they had a challenge to find out the best route for parcel pickup and delivery across the country. So we have a challenge. The first is that they want to show the parcel pickup and delivery on the map, and also they want to identify the highest, the passes with the highest degree of parcel traffic in the country, and also they need to know that what are the alternative routes for these high traffic passes. So these are our problem that we are going to solve using our solution. This is the experimental event log that we have used in this work. This is the enriched event log, not the original one. The original event log has just the information related to the case ID, event ID, and timestamps and activities, as shown in this picture. The case ID refers to the parcel number. That is a unique number for any parcel. And also we have a series of events for each case that are defined using these 4 activities. Each parcel is picked up at the source destination here, for example, in the city of Mashhad, and it ends with the parcel delivery at destination, for example, in the city of Shiraz. And there are a number of check-in and check-out that conduct in different post office in the past from source to destination. But in the original event log, we didn't have any location. So we first enriched the event log with the geographic location and included in this experimental event log. So in this process model, we can, I want to mention that a discovered process model shown in this picture is started with the pickup and ends with the delivery. But we can look at this event log at in a different way. For example, if we consider the city property as activities, we can see a different process model of using this event log, as shown in this picture. If you select the city as activity to discover process map, we can find out that there are some nodes depicted in this picture that shows the location that the activities, it means, sorry, not location, it's the name of the cities that the activities are conducted. For example, when we filter the parcels that are transferred from the Mashhad, city of Mashhad to city of Shiraz, we can have this process map. And also we discover the process using the prompt as shown in the right picture. This process model gives us insight to how the process are executed. For example, we can see that these 2 paths, this one and this, are the most highly trafficked in this figure. But they cannot provide us any geospatial perspective on the process. So what's our solution? Our solution is geo-enabled process modeling that has 3 main benefits. The first advantage is that geo-visualization of business process, it means that visualization on the map. So it increased process interpretability. So we can see that if we have the process like this, we can see that each activity placed on the exact location that happens in the real world. So we can gain a better understanding of how the business process are executed in the real world. In other words, we can say that geo-visualization makes the process model more explainable, and we can see that why this process has delay or how it can be drawn in an understandable way. The second advantage of our solution is that by enriching the event log with geotag, we can incorporate the location-related metadata into process models. For example, we can include information related to the roads, such as what is the maximum speed in the roads, or what is the number of lanes in the highway. Maybe these features are affecting the delay in the process. And another benefits of incorporating location-related metadata is that we can benefit from location hierarchy because we can see the business process at different abstraction level. I mean that we can see the process model at the different granularity. For example, we can filter out the process that happens at the level of post offices. We can filter out or on the higher abstraction levels, such as cities, or even countries. When we have an international process model, we can filter the process at the level of countries. So the location hierarchy is a very useful feature for us to better analyze the business process. And the third feature...
Besit,
yes?
Excuse me, do you have 2 minutes? Okay.
Yes, I know. I have a little slide to finish. And the third benefits of our solution is using location-based metric to assess the process performance. So in this example, we have the same event log and drawing it with 2 different tools. On the picture on the left is a process model, process map that depicted with the current tools, and the picture on the right depicted the process model using our tools. As we can find out, there are 3 ways from this source to this destination, but by this feature, by this process model, we cannot understand which path is the optimal. But on this, on the picture on the right, we can find out that the blue path is the best path because it has the minimum distance between source and destination. We have developed a tool suite to present our solution, and the name is MEEM. It stands for Meeting of Events and Evidence on the Map. We can incorporate all external information at different levels on the map if we have the geographic location. For example, we have different levels for cities and for countries, for post office, and different levels of hierarchy. And also we have some information that are extracted from the event log. So it's the intersection of events and evidence. Events are the data that comes from events perspectives, provide us the information that are related to the process activities happens in that location, and the evidence perspective provide us valuable location-related data available in external data source. All of the materials about regarding these tools, including the code and the data sets and a demo on our tool, is available, publicly available at GitHub. So to conclude, we can say that we contribute to process mining by introducing our solution named Geo-enabled process modeling, and we have just confined to drawing a simple presentation of process graph on the map. And in our future work, we are going to implement a location-based metric, distance, for the assessment of process performance along with the execution time. Thank you very much for your attention. I would be very happy to hear your feedback on my presentation. Thank you.
Okay, thank you. Any question? Let me know if there is any question. No. Okay.
So I can ask a question. I'm using the Zoom link. That's why I cannot click the button.
I'm sorry, Will.
So a question that I would have is that there is the work of Massimiliano De Leone of about I don't know, 10 to 15 years ago, who extended both workflow environments like YAWL with the geographic visualization of work items. And this was then later translated into visualizing, let's say, process mining results on any map. So what you would see is you would see, let's say, basically what you were showing, but on top of that, you would also see the, let's say, the cases really flowing between the different geographic locations. Did you take a look at that work? And if so, why didn't you use that? Or did you compare it?
Thank you very much, Professor. The tool that we have developed is customized for this use for post companies. So we have presented two different perspectives on the same frame. The first perspective is the event perspective that the data comes from the event logs, such as the work that you have mentioned. And the second perspective is the context is related to the contextual information that comes from the external data source. So we bring these two perspectives in at a glance in one tool. This is the difference with the work that you have mentioned.
But the work that I refer to, there, let's say every event has a geographic location. And based on the geographic location of the event, it is visualized on a map. I do not see what you can do that would not be possible in this PROM plugin.
I'm not sure that works can filter the process model in different level of granularity. Is it possible to filter the instance by the level of the hierarchy? For example, to filter the events happen at a specific country or at a specific city or a post office, for example?
Because this is in the context of PROM, you could combine it with any of the other plugins. But in the end, what you would visualize is, let's say, are the geographic locations of the different events. And on top of what you showed, what looked very spectacular at that point in time, is that you also see the cases moving geographically through the process, if you see what I mean. But because it's in PROM, you could combine that with any plugin to filter your data to show something specific. But Prati, we can, I can send you a pointer to the paper if you want.
Thank you very much. Thank you very much for your great feedbacks, Professor Van der Als.
Okay, we have another question in the question answering chat. The question is, in relation to incorporate location-related information, do you think your method could be combined with elements from graph theory, for instance, shortest path? As mapping a graph to a map is easy to do. The question is, do you think your method could be combined with elements from graph theory?
In the first version that we have implemented for the National Post Company, it's not possible, but we are going to extend it as a module to for PROM, and then based on that model, and in the second version, the extended version, we hope that we can address it.
Okay, thank you very much. And with this presentation, we finish this session. And now we move to the second session of the Industry Forum, which starts in 2 minutes. Okay, thank you all.
Thank you very much again, and I do apologize for the interrupt that happened in my side. Thank you.
Thank you for everyone.
Thank you very much.
Yeah, thank you everyone.
Ciao.